Let's talk about some kinds of errors in sensors. The errors in a sensor can be divided into two kinds of errors. One is called a systematic error, and another is called a random error. And let's talk about these two kinds of errors, systematic and random errors. As we go along, what I would like you to keep in the back of your mind is think about accuracy and precision, and think about how systematic and random errors are related to accuracy and precision. Okay, I will not answer your question in my video, but I will ask you after the video as to what the relationship is. So, systematic errors are errors that do not change when measurement conditions do not change, or they change predictably when conditions change. Okay, so let's say you're measuring a quantity using a sensor, and as you measure the quantity again and again, an error keeps appearing, exactly the same error, same value of error. That is a systematic error. Let's say you change the input quantity that you're measuring using the sensor, and the output of the sensor changes. There is an error, but it changes systematically. As you increase the input quantity, the error also either increases or decreases in some way. So there is a predictable quality about the error. Such errors are called systematic errors. They are called systematic errors basically because the error is not happening because of chance, but because there is an error in the system, right? And that error could be either because of the instrument itself that you're using to measure, so which could include your sensor, your electronics, etc., or it could be the method that you're using to measure. So what is the measurement technique that you're using? So both of these could contribute to systematic errors. um, Random errors, on the other hand, are errors that remain after we eliminate all systematic errors. Okay, so let's say we have detected systematic errors and we have eliminated all the systematic errors. There are some errors that are going to remain, and we are not able to eliminate them at all, and they do not have any predictable quality about them. They are random, and so these errors are called random errors. Okay, random errors basically have a few properties, and the properties are that positive and negative errors are equally likely, right? So the uh, larger values of errors are less likely than smaller values of errors. And if you take repeated measurements, the mean of the errors approaches zero. So basically, what we are saying is that that there is a kind of an error at the output that is changing from measurement to measurement. It can be sometimes less than the true value, sometimes greater than the true value. And if you take a mean of all of the values at different measurements, the mean becomes zero. Okay, how do we figure out whether a system has a systematic or a random error? Well, random errors are easy to see, right? Because once you repeat the measurements again and again and you see these variations, you know, well, there is a random error. Systematic errors are, of course, are more difficult to detect. You can only detect a systematic error if you change the method with which you are measuring a particular quantity. You change the method and you see that you start getting different results, and they say, oh, what's happening here? With this method I'm getting this result for the same quantity. With this method I'm getting a different error, different value. So there has to be a systematic error in the system. Okay, either in the first method or in the second method or in both methods. Another way to figure out systematic error would be to get a validated instrument from somewhere, an instrument that has much less errors or that is more standard, and measure the output of your sensor or your instrument compared to that instrument, to that standard instrument. That could also reveal systematic errors. In general, systematic errors are much more difficult to figure out than random errors.